All righty. So welcome everybody and happy, what is today, Tuesday? Yeah. We're almost, coming down to the end of the semester. So thank you so much for being with us. And I look forward to presenting you right now to three of our presenters. Dr. Yu-Chung Chang, who is a mathematics professor here at Pasadena City College. And we also have O'Neill Duglin and Shu-Chen Liu. And they're going to be telling us all about their research with blockchain. Let me briefly tell you a little bit about Dr. Yu-Chung Chang. She attended not only UCLA, but New York University and Caltech. So she is a great resource of information if you ever want to inquire about those colleges. She is also the mastermind behind our yearly Pi Day event. So if you ever want to be part of that event or contribute to that in any way, she is our touchstone on that. She has been working on blockchain research and molecular dynamics for quite some time, and we are very much looking forward to learning more about that today. So if I could have O'Neill and Shu-Chen introduce yourselves and tell us a little bit about yourselves, that would be wonderful, and then you can take it away.
Hi, so everyone, my name is Shu-Chen, and I am a student of Pasadena City College. My major is computer science. Yeah, thank you.
Hi, everyone. Nice to be here. My name is O'Neill Duglin, and I'm too a student of Pasadena City College, and my major is computer science. Thank you.
Very nice to meet both of you. All right, so please go. Your presentation is showing, so you are more than welcome to start anytime you'd like.
Wonderful, wonderful. So welcome everyone. Today we're going to give a presentation to the blockchain tool, which we all have worked for quite some time since last summer. And then we would like to share our experiences of undergrad research, which you may consider interested to join in the future. Blockchain is a very interesting technology and underlies many digital currencies, including Bitcoin and FTs that many of you may have heard about. And we're going to tell you and let you code later at your own time and show you how you can create an account in NanoHub. And we are going to let you look at the code and see that it runs an actual blockchain. And the way we are going to organize today's event, that we will have this short introduction by Shu-Chen Liu, and then we are going to have this presentation of the tools, continuous by O'Neill, me, and then we're going to let you know how you create the account, and then you can play around and maybe you will be able to create your own blockchain code yourself. Okay, so without further ado, Shu-Chen, would you please take it away? Okay, so here, I would like to first share about my little experiences about this undergrad research starting 2020. Actually, it was after our annual event, I learned about the undergrad research opportunity. So I started joining as a participant and also try my best to help students if possible. So what I have involved was the following. We try to investigate whether we can increase the participation and engagement in community college level and make it very engaging for all classes if possible. And so that we can bridge the research opportunity gap between community colleges and universities. We know that as of two-year college like PCC or other community colleges, we do not have that much resources. So we try to see how we can enhance that. And through, some collaborations and work. Actually, it was under COVID-19. So everything happened, through the Zoom. What we have done is we design modules of data classrooms, food labs, and standard curves, and introduction to Pythons and several labs to help students to increase their participation and engagement. And we actually published a paper on ASEE last year. And after that, I joined this blockchain research group, which we are going to present you what we are doing now. And I also involved with the main role PCC team, and they are going to join a competition in June. And we would like to start introduce what we have done on the blockchain. So Shu Chen, you can go ahead. Yeah. And first of all, we would like to have some acknowledgement. Professor Ali Strachan from Purdue University is our lead. And many thanks to Professor Ashcroft at PCC that he is the key person, bring all of us together. You can see this is a collaboration between PCC and Purdue University. And our students like O'Neill or Shu Chen and me, we are collaborating with Professor Strachan and his postdoc or research fellow or graduate student. And we also work with Professor Fulton, and they are like support to all this research. So we really want to share our experiences with you so that maybe you will have opportunity to also be part of this network in the future. Okay, so Shu Chen is going to give us some introduction for the blockchain.
Hello, everyone. So first of all, I want to introduce, everyone think about what is money. So the money is a medium of exchanging value. We could use the money to exchange goods. You can bring the money to the supermarket, you can buy the food. You can buy everything you want. These are kind of, these money shows here are kind of money which is issued by the government, also called government issued currency. They can be the medium of exchanging value because people trust the government who issued the money will not cheat. And here's some digital transaction of the money. We use credit card, debit card, PayPal, Venmo. We purchase stuff online, and this is a ledger. There is a ledger, A than $5 to B via PayPal. All these transactions are clarified by the bank. This is called centralized ledger, which all the transactions have to clarified by the bank. And PayPal, credit card, debit card all belongs to this, the centralized ledger. And now we have the cryptocurrency, Bitcoin. Cryptocurrency is a digital currency and can be used as a medium of exchanging as well. Here are the cryptocurrencies. The most famous one should be the Bitcoin. How is the difference from these different from the PayPal, GPay, and Google Pay and Venmo? The big difference is that these payment methods are centralized, whereas the cryptocurrency are decentralized. Cryptocurrency are the kind of money which issued by blockchain system instead of the governments. They can be the medium of exchanging value because the proof of work system is non-cheatable. Bitcoin also use the blockchain technology to create a database of transactions. So all the transactions are decentralized. We don't need a bank to verify it anymore. The blockchain system itself is non-cheatable. And then here we have non-fungible tokens. So before I introduce what does the non-fungible mean. So what does fungible mean? Fungible token, for example, there is no difference between 1 Bitcoin in my hand and 1 Bitcoin in your hand. They are totally same. This is called fungible. Non-fungible token is like the dollars with a serial number. There are no $2 with the same serial number in this world. And there are no two identical non-fungible tokens. The non-fungible tokens database is also a distributed ledger and use the blockchain technology. So here is a blockchain. Blocks are these are blocks and they are chained together. We call it blockchain. Each blockchain contains verified transitions. A paid 5 Bitcoins to B, B paid 1 Bitcoin to C. All these transitions, before all these transitions, we need to verify by the bank, but now it's all verified by the proof of work. So proof of work is needed to verify for each transaction. So here is a block. This is called nonce. And this is called hash. The nonce is an integer. And the hash is a unique alphanumeric string mapping the data and the nonce. Here is an example of nonce and an example of hash. Proof of work is the process to find the nonce such that your hash value start with 40. So this hash is start with AB12. It's not verified by the proof of work. This one start with 20 and FG is also not verified by the proof of work. This one is start with 40. This one is verified by the proof of work. So here is a demo which how blockchain works. Since the hash, since the blocks are chained together, once we modified one blocks, will make that block all subsequent blocks are invalid. As you can see the change of this. We add C paid 4 Bitcoin to E, then the hash is not start with 40 anymore. So so here is all verified by our proof of work. But once we modified one message here, the hash will change to a hash which not start with 40, which is not the verified by the proof of work, which will make this block invalid, this block invalid. Yeah, and this is my introduction of the blockchain. So our next presenter will introduce about the blockchain tools on the Nano Hub. Thank you.
Thank you. So actually, even for people who are, doing the investment on the blockchain, many of them, they not quite understand the behind logic or mechanism. And that was one of the important motivation for us to create this educational module. We make it available to all people. If you are interested, you can create an account on NanoHub And the link on the top is connect with our tool of blockchain. Once you launch the tool, and then you are going to be connected with a landing page. So next slide. So clicking the launch tool, you will see the blockchain tool and its landing page. And that will have several notebooks that created by our team. And now I'm going to have O'Neill to start with the live demo.
Hi, everyone. Here I'm going to present to you the live demo of the blockchain. Okay. Here we're on the landing page, and on the landing page we have several modules. The first module we have is the live demo, which I'm going to go through with you quickly, and then the other modules that we have is like the blockchain code, so you can actually see what the code is that goes into making a blockchain. We also have the hash, which is char256, and you can see the application later and the code. And finally, the proof of work. So we will go through those later, but first I'm going to start with the live demo of the blockchain. And it's similar to what Shu Chang was showing you in the PowerPoint presentation. In this case, it is done in Python. So we're going to show you, we're going to use Jupyter Notebook to illustrate the blockchain. So when you first load the live demo, you get a block. You get 4 blocks actually. So we start with the Genesis block, and we scroll down. You have first block, then that has a transaction, and third and fourth block. So right now we start with 4 blocks, and each block has fields. The first field is the index field. What that does, that is the position of the block within the chain, because as you remember, it's a blockchain, and we are going to how they are linked together. But the index field is the first that just indicate the position of the block in the chain, and this one start with 0, and that might be unfamiliar to some of you, but in computer science, everything start with 0 as opposed to start with 1. So for us, the first block starts with 0. Then we have the nonce, and we use the nonce to help generate the hash. To help perform the proof of work. And then we'll go into some more details of that later. The data is whatever you want the data to be, but in our scenario, we're using transaction as our data. Our first block in this case is the Genesis block, because each blockchain has a first block, and it's always the Genesis block. And this block there's no block before this. This is the very first block in the chain. Previous hash does what is used to link each block to the one before it. In this case, this doesn't have any block, so we just added just some zeros. And finally, we have now the hash. And the hash is what we use to perform the proof of work. In this scenario here, right now, this is a valid block because it hash start with 4 zeros. And then the block below it is similar, that also start with 4 zeros. But if you check, you see the previous hash here links this block to the first block. And each block is like that. The block underneath is linked to the block above. And this block has a different transaction, a different nonce, and the index is 1. So now what I'm going to do, I'm going to show you what happens when you break the blockchain. So I'm going to come down to what would be the third block, and I'm going to cheat. I'm going to say that we paid Dr. Chang $80. Now, what do you think will happen when I do that? Anyone have any guess?
Make everything else invalid.
Thank you. Yes, every block underneath this block becomes invalid. So this block becomes invalid. You see the hash now doesn't start with 4 zeros. It's still linked to the previous block. There's no change to the previous one. The previous one is still valid, but every other block underneath this one is valid. This one, all of these blocks here became invalid. The previous hash is invalid and also their hash. So one of the ways that we can make this cheat valid, and it's pretty difficult, but we simplify it. One of the ways you can make this cheat valid is by changing the nonce, by using the nonce to try to find a hash that starts with 4 zeros. So if I was to increment the nonce, you see that the hash changed automatically as well. The hash gets updated. And as I keep doing that, you can see it's not getting any closer to starting with 4 zeros. And it can take a very long time for me manually trying to figure out what nonce to make the hash start with 4 zero. Also to note, the inputs for the hash is the index, the nonce, the data, and the previous hash. All these fields above is what is catenated and used to generate the hash. And later on, we will explain that process a little in more detail, but those are what are used to the hash and catenate. And so since it will take me a very long time to figure out what nonce I need or to make this change valid, I will have to, I can use our computer by clicking the mine, and by clicking the mine, we use the power of the computer to figure out what's the best nonce to use to make this now a valid transaction. So when I click on that, you see it's 8,609. And before I was in like 55,000 and something. So you realize it would have taken me a very long time to figure out what would be the valid nonce to make this hash valid. But I'm not done, because this now becomes valid, but I still have to go now and repeat the same step for the foreign blocks. So you can imagine, let's say this was like 1,000 blocks I had underneath. I got to go to 4,000 blocks and try to hit mine, and that can take a very long time to make them all valid. So that's one of the reasons why they say it is difficult to solve but easy to prove that someone has tampered with a block, because you can look quickly at the hash and see that it's not correct, and then you can say, oh, this someone has tampered with something within the block, and you can see from where they have tampered with it. And one of the other things you can do with the tool, because obviously they started with 4 blocks, we can also add a new block. And when you add a new block, that block all adds at the bottom and it's invalid because no proof of work has been done to that block. So let's say I enter a transaction here. Only pair Dr. Chang here, say $5. So now the transaction is in, but I need to perform the proof of work. Now, the proof of work is obviously using my computer mining to make this hash valid. And by clicking on that, now the system found a valid nonce, which is over 100,000 to generate a valid hash in this case. This one created 5 zeros, but once it begins with 4, it is valid. 4 and anything else makes it valid. Are there any questions from anyone before we continue? Okay. So now I will let Dr. Chang, she will present to you guys how the more in depth into the proof of work and SHA-256.
Okay, so now let me share my screen. Okay, what we would like to say here is In the landing page, we have this live demo that just being demonstrated by O'Neill. The reason why we had this introduction to SHA function and the proof of work is because we would try to make this an educational module for all people who would like to learn blockchain. So we start with this very simple and basic SHA-256 function. So if you click SHA-256 app, you are going to come to this module, and that allowing all of us to type in data and see what will be the result from the SHA-256. Well, SHA stands for Secure Hash Algorithm, and there are many such crypto hash functions like SHA-224, SHA-512, but we just select SHA-256 for our purpose. So now here, let's type in hello world. And you can see if you click the hash me, it's going to give us the hash result, which is a 64 characters involve letters, characters, and it's a numeric, alphabetic numeric string. And if we change all of this to upper cases, what would happen? The result of the hash will be very different, okay? And actually, it is a unique output. So if we change back to the previous hello world, you're going to see after you hash me, it's going to change back to the original hash result, starting with A591 and so forth. So this is a very straightforward introduction about understanding what is this SHA-256 function. And next, we would like to introduce you about this proof of work. So on the landing page, if you click this proof of work app, you're going to come to this module. This is one block, and it has field of nouns and the data field. So let's type in some transaction in the data field. Let's say A paid a Pi Day 2022 t-shirt, which is a non-fungible token, to B. This is a transaction, okay? And let's see what would be the hash result. Whoa, okay, it is 4CF675. That is not starting with 4 zeros, as what O'Neill just explained. To be a valid block, we would like to increment nouns continuously until that we have 4 zeros at the beginning of the hash result. It's going to take a long, long time. So we use, computer to help us. So if you click this mine, it's actually, it's going to have a systematic loop to help us to find that nouns. So after you click the mine, you're going to see, whoa, the nouns that make it hash with starting with 4 zeros, it is 94,623. It's a huge number. So we can see that it's not easy to solve this problem, to make this block valid. However, it is very easy for us to see whether it is a valid block because we just need to check whether there are 4 zeros at the beginning. So this property, hard to solve, but easy to verify, is a very important property for this proof of work. Okay, so now we hope this notebooks that we created for this whole tool for blockchain will help you understand the underlying logic of the blockchain. And when you have time, you can play around and hopefully you can start coding your own blockchain at your leisure time. Okay, so this is our brief introduction and presentation for the blockchain. Any questions so far?
Good question. There is one question.
Okay.
I'm just curious in regards to proof of work, is it just basically the permission to manipulate the information?
Would you please say it louder? I'm so sorry.
Could you please explain more about the proof of work?
Oh, okay. All right. So proof of work. Okay. So the proof of work is to validate a block. So, okay, in the real world, okay, when people doing this mining of this Bitcoin, they have to solve very, very, very hard math problems. And to demonstrate that they actually has done the work to mine the coin. And actually, you asked a very good question, why we are doing this research. It's not that because we are going to invest the Bitcoin. It's because that we noticed that there's so much computer power has been wasted in this, mining Bitcoin. So Professor Strachan in Purdue University, he is hoping that is there any way we can develop a blockchain that use molecular simulation as the proof of work. In other words, instead of solving some very hard but not really meaningful math work, is there a possibility that people can solve a molecular simulation, which is also very hard as proof of work, so that we can use the energy used by the computer to benefit the scientific community? Okay, so the proof of work here is a very hard, just like what you see that if you say we would like to have the block to be valid, if the hash result has 4 zeros at the beginning, then you have to keep increment the nonce until that you get that result, right? So the proof of work is the work to validate a block in the blockchain. So in the real world, it's very hard. Right now, we just require 4 zeros at the beginning. But how about 100 zeros at the beginning for the hash result? It's going to be a long time for us to, to find the nonce to reach that 100 zeros, right? Right now, it's just for demonstration. So we use 4 zeros as the requirement for a block to be valid. Is that clear to you?
Yeah, I'll dig deeper later. Thank you.
Very welcome. Yeah. Okay. So also maybe some of you wonder, what is this input for the proof of work? So here we have nouns, we have data. The concatenation of the nouns and data is the input for this proof of work block. If you are going to go back to the hash, so you can see, let me use the nouns to be 1, 2, 3, 4, 5, say, all right? And then I'm using this data. A paid a Pi Day 2022 t-shirt to B as the data. And I'm going to concatenate the nouns and the data. You can see what is the hash right now? D498F, right? And so forth. And let's see if we go to the SHA-256. Okay. And then I'm putting 1, 2, 3, 4, 5 the nouns, and then paste this data. This is a concatenation of the nouns and the data. Previously, you can see the hash result is exactly the same. A 5, 9, 1, 8, and so forth. Okay, so hope that make it you know, a little bit clear about how this work in terms of input and output. Cool. Any more questions?
I have one. Is 64 characters for the hash like the standard?
Yes, for this hash function, yes. No matter how long is the data, it's going to generate 64 alphanumeric string as the result.
And is that for this demonstration? Because
Yeah.
you mentioned before having 100 zeros as the criteria. So could it be longer?
You got the right point. I shouldn't say 100 point for this case. Yeah, I would say, I think this is for this, for our demonstration. Yeah, for our demonstration, it wouldn't be 100 zeros for sure.
Okay.
So what would be the, I guess, the typical hash or the number of characters on a typical hash being used right now as a, let's say, Bitcoin blockchain?
Excuse me, can you repeat the question?
What would be the amount of characters you would find on a blockchain being used for, say, for like Bitcoin or something like that?
Oh, for that.
I believe it is much more
Yeah,
than the 64
yeah,
because
for
the
sure.
last time we researched it, it was for the zeros, there were something looking like, I think it was either 16 or 20. So I think they might be using a longer hash than what we
Yes.
are currently using.
Yes, that's correct. Thank you.
Thank you.
Good. I think many of you may be wondering how O'Neill and Shu Chen get involved with this research. And we really would like to share some of our experiences. So maybe that will shed some light. If you are interested, you can join us, or maybe there are other opportunities that you can participate. So I would like to have O'Neill to start and sharing his own story.
Okay, thank you, Dr. Chang. Hi, everyone, again. My story in terms of getting involved with the another research project is an interesting one. First, I'm a first generation student, which means, as your parents never attend anything higher than high school. So I'm first to, well, myself and my sister, which she finished, graduated college, but I'm also first in terms of, going to college. So, and for me, it's very interesting because I also came from Barbados, which has a different educational structure to what is in the United States, because Barbados educational model is on the English model. So coming here to America and then going to college, some stuff was different to what I am accustomed to, but so far it's been great. My major, as I said before, is computer science. Why I chose computer science is because when I was living in Barbados, I was a programmer and I wanted to get a degree, to fit that my experience. I know there's degrees in software engineering, but I wanted to do computer science because I think that is that gives you a broader scope because you get exposure to hardware and you get exposure to software, and I was able to get that exposure to in the research projects that I did. Right. So how I learned about the research projects, I was introduced to Dr. Ashcroft, and he's responsible for the Micro Nanotechnology Educational Center. And through meeting with him, he told me about the different research project that is available. And and I told him about my background and my major. And so we was able then to find a project that will allow me to use my experience, or, get the experience I needed for my major. So, and that started in 2021 summer, where they had a hands-on research project in New Mexico, at the University of New Mexico, where we learned about nanotechnology. And that's how I started with nanotechnology, which is very interesting, and the field is growing. It's a very new field, and a lot of research and development is being done in that technology, for nanotechnology. It's these things that is so small that you have to use a very powerful microscope to see them, but it's very interesting in the application where they can use them in medical and other industries. So one of the things we did there at New Mexico on that hands-on experience was that we was introduced to a clean room and learned the clean room procedures. And the clean room is like what Intel used to create their chips. So we went through the same process as if we was at Intel. Obviously, we didn't create any chips, any CPUs that you will find at Intel. In that one, we created something known as a micro pressure sensor. And it's just a simple sensor that a lot of industry use, like the sensor could be found in washing machines to make sure that the drum is balanced. You can find the same sensor in a glucose monitor. You can find the sensor also in like those wristbands that you put on to measure your blood pressure and so that one sensor is in a lot of things, and we was able to create that going through the same cleaning process and the same technology that Intel to make a CPU, but in this case we just made a simple micro pressure sensor. And that was very interesting because for me, I didn't know anything about this kind of technology. This was the first time I was being exposed. I knew about hardware and software, but I didn't know that, about the procedures in the clean room. So that was a very interesting, that's how I started. And that started me to be very interested in research projects. And then from there, so I started then the blockchain technology at Purdue University. And that one wasn't that was remote. So it was mostly learning about molecular simulation. And that was an interesting thing for me because I know about simulations, but in terms of molecular ones, where you go and use the computer to generate the physics for how a material will interact in the real world, that was a very interesting part of the beginning of the project, because as we said before, we want to use the molecular simulation as our proof of work for the blockchain. So we needed to understand how those simulations work so that when we get to the part of implementing it, then we got some understanding of what it is. The challenges, there were some challenges. First, there's a lot of reading. I will tell you, there's a lot of, you have to do a lot of reading, and the literature that you get is a little more advanced of what you might come across in school, or even what you might read right now at community college, because I found that some of the information was a little more than I understand. But the good thing about research project is that you have a lot of mentors that know this information, and that they can break down that information to make it simpler for you to understand. And I found that was a great help, having all those mentors from the different universities assist us. So that was a great part of the process. The other thing was obviously the math. The math was from molecular simulations, or it's graduate level, it's PhD student level math. So it was a challenge at the beginning, but as I said, we have mentors that help us break down and understand the different concepts and how to use the math for the simulation. So that helps too. And obviously, one other thing I had was time management, being juggling the research and also doing school. I can say the first project, which was at the University of New Mexico, that was in the summer. So I didn't, and that was in New Mexico, which means I didn't take any summer class that year. So that was a little bit easy. But in terms of the blockchain, that was going on was I was still taking classes. So I had to, juggle, do some juggling. And I found what works for me was to-do list and Google Calendar, by putting in all your different assignments and your different tasks in Google and keeping those in Google Calendar to keep you on schedule. I found that helped with the time management, because sometimes things can get out of control quickly, especially when you're studying at school and then you're also doing this additional studying for the research projects. And in doing that, I found some stuff that we did on the research project also lend itself to school as well. And the benefits for me, I made some new friends, some friends that I would not have met, because my background is computer science, but some of the people that was on the research project also have background in chemistry and biology. So you can see you will see there was a different mixture of people. So it was great to meet new friends that way. It built a network inside and outside PC, because I also know faculty members at PCC, as well as faculty members at University of New Mexico, Purdue. So it helps bring that network, and you get to learn about other stuff that's happening in the industry, because you get to meet professionals in the industry. On the New Mexico one, and I'm going to be quick so that someone else get it. We was also introduced a professional businessman that started his own nano company, making these different things. And we was introduced to him, and he showed how he manufactured. So it was very interesting in learning about what's going on in the industry and actually seeing it, actually being there in the facility, people making it and testing it. So that was a very interesting part of the process. I obviously travel. I had to, one, I had to go to New Mexico, but the other one with Purdue, that's remote. So our research doesn't have to include travel if you don't want to. Some could be remote, and some you can actually have to physically go there. But you get to choose what you want to do, which is great. And you learn new technology, and I learned about careers I never even knew existed, which was very interesting. Like a lot of new careers is coming out of the clean room, as well as research labs, stuff that they need people like to maintain the equipment or to build the equipment. So it was a lot of different things you get to get exposed to, stuff that you normally would be exposed to. And for me, I would recommend that anyone is thinking of taking a project, you can do it in the summer. You don't have to do like me. I was different. I did several projects, one after the other, but you can just do one and just see what it is. And usually I can say when you talk to the mentors and you tell them what your major is, usually you will get stuff in line with that. So like you don't do stuff that you couldn't use then later on in your career. So which is a good thing. And sometimes it even open your eyes to other careers that's out there. And that is my experience. So I'm going to leave the floor to the next presenter. So Shu Chang, whenever you're ready, you can present your experience.
Thank you, Neil. Hi, hello again, everyone. So I heard about this program from the Professor Chang, and I heard that this project will do something about the blockchain and Python programming, and I was very interested in this. So I decided to join in. I reached out Professor Ashcroft, and he bring me to this research team. After I joined the team, I start to learn what I didn't know, but what was needed for this program. So the members of our team all have the diverse academic background. For example, me, I have some knowledge of blockchain and Python programming, but I haven't studied a lot of college level physics and chemistry. And this is a big challenge for me because some chemistry knowledge are graduate level. It's very difficult. But after all, I still make it. I learn these skills, or I learn this knowledge which I'm not familiar with through the video lecture at first. Then we will have a weekly office hour to discuss. Dr. Chen will also help me with it. Okay, some my other during this process, I get a lot of benefit and I learn a lot of things. Not only the knowledge on the textbook, but also some the knowledge out of the textbook. For example, how to processing the email, communicate with our team, making PowerPoint, how to do the presentation. These are all the important skills where you can use everywhere, every career you are, every career you are. And so finally, I would also recommend other students to join this research. I am a first generation immigrant, and English is my second language. So there's a lot of there's the learning process and the communication process will harder for will more difficult, it'll be more difficult for me. But now after all I make it. So I think this is a very good opportunity for students who want to try to get this scientific research, and this is very nice experience. So yeah, thank you. This is my yeah, thank you. And the Dr. Chen will share share hers, and the yeah, thank you.
Okay, I just shared this last slide with all of you about what is needed and why you would like to do it and how we can do it. I think it's very important that for all of us having this open mindset, as long as you are eager to learn, you are qualified, and as what you have heard from O'Neill and Shu Chen, it's a lot of teamwork, and you are having opportunity to meet with good friends and like professors or postdocs, that it's going to be part of your future network, right? There's one thing you need to keep in mind is time management. It is very important that you keep a balance between the school and the research. We do meet from time to time, sometimes a regular meeting, office hours as well, and sometimes it would be upon the need, and sometimes would happen during the weekend. However, I think the joy of applying your knowledge and skills to real life projects is something beyond the words. What you can, you can feel from O'Neill and Shu Chen, they all feel very, very happy and rewarding, and there's a lot of fun. The last thing I would like to tell and share is, after joining this kind of research, actually there is a we call snowball effect of opportunities, because now you reach out to people who are not just inside the classroom. So you get to know different, people either in different universities or different industry, having different, coordination or collaboration. So you meet with different people. And so people would, will pass around different opportunities. So I call that is a snowball effect of opportunities. And we have learned from previous students that once they get one internship, they get a lot more after that. It's just because it all built on the previous experiences. So I welcome you and I inviting all of you to consider to join, one or even more than one such kind of undergrad research opportunities. If you have any questions, please feel free to ask.
Yeah, I just want to add that to what Dr. Chang said in terms of the snowball, it's definitely true. You learn a lot. You learn about stuff in your major, and also definitely for me it was a snowball effect because I went from University of New Mexico to Purdue, and right now I didn't say it in my slide, but right now I'm also working with Caltech. So it shows you how stuff can, how you learn, and what you learn from one thing, you can use it in another area, and that's what I'm also doing at Caltech. Some of the stuff I learned at Purdue, I'm also using at Caltech. So that's very interesting because all of these programs make sure that the information you're getting is geared towards your career and your major. So it is not busy work, it's stuff that you can actually.
Thank you, Neil.
Thank you so much. Would you maybe mind stop sharing screen for a sec? Thank you. Okay. So,
Thank you.
Okay, no problem. So I just want to say thank you very much for sharing all of this with us. I think that it's the last points that were made, it was all very interesting. And I know I learned something about blockchain, especially why it's called blockchain. Makes so much more sense now. But I want to reemphasize the last points that were being made about connections. And if you did not attend the Friday talk by David Kagan, he talked about his journey from PCC to Caltech, and really it was his journey from being homeschooled to ending up in Caltech. And the catalyst was starting somewhere. He started with getting a tutoring position, and he got a faculty member to, connect with and provide a letter of recommendation. With that one connection, he was able to snowball, for lack of a better word, I think that is a great word actually, into other connections. So any extracurricular activity you do gives you not only the experience with that, but connections to people and other opportunities, which you can really leverage and grow into other better and things that you would never have even thought of that will come, your way. So thank you, Yu-Chung and O'Neill and Shu-Chen for this talk. And I hope that you've inspired people to dabble a little bit in your research because it is very interesting and it's really one of the biggest things going on right now. So thank you so much. And thank you for sharing nanohub.org with us so that we could play around with that and hopefully also continue to inspire a little bit more curiosity. We appreciate your time. And again, thank you for all of the information.
Thank you. Thank you. And I will send you some information about creating the account under NanoHub, okay? So you can share with students.
Oh, wonderful. Yes, we'll include it on that AW page. Thank you.
Okay, thank you. Thank you, everybody.
Have a
Thank you
wonderful day.
guys, have a great day.
Thank you, everyone.
Do you mind if I ask one question?
Oh, we have a question if there's time.
Oh, sure, sure.
I'm just curious. So I know that, like, let's say we invest, like yield farmings and all this stuff, we need to pay for gas fee, right? I'm just curious. Besides some part of it goes to the owner of the platform, what about the rest of those gas fee? I think it's kind of like interpreted Western.
I couldn't get the, I think that the sound was a little bit low. Is it possible to be repeated?
Yeah, so in terms of, let's say, we're investing Bitcoin or other coins, there's going to be, gas fee and all this stuff. I know that part of it will goes to the owner of the platform, which we use like PancakeSwap, whatever. What about the rest of it?
So the question was, if part of the fee, when you purchase,
It's like gas fee.
there's a gas fee, where does the rest of it go? Where does the remaining fees go? Oh, O'Neill, you're muted.
O'Neill, you are muted.
Yeah. I understand the question. Dr. Chan, do you know, or Chu Shan, do you guys know where the rest of the fee goes? For me, I don't know. That of it, I definitely don't know. Yeah.
I myself don't know, but we can definitely, find out
Find out,
and
okay.
get back to you, in the next few days. Is that okay?
Yeah.
No worries. Thank you.
Yeah. So Sylvia, please note for us, and then we can get back the answer to you, and you
I
can.
will, thank you. Thank you so much.
Very welcome.
Have a wonderful day, and thank you again. It was a pleasure.
Thank you. Thank you.
And for those of you who attended, I did take online, I did take roll, but please go ahead and, for my double checking, just go ahead and type in block into the chat. And I will make sure to write double check my list.
Yeah, that would be a good idea. If you can type in your name and questions, we can try to get back to you.
Yes, that's a great way to do it too. Yes. Thank you. Bye, Jose. Have a good day. Thank you very much.
Okay, thank you.